This video is on pH and pOH calculations. So we've learned already about the pH scale, but how is pH determined? We can do it a couple of different ways. We can use a pH meter in the lab, we can use pH paper, or we can use other indicators that tell us our pH via color. For all of these, they're measuring the hydronium ion concentration, also known as the hydrogen ion concentration. The pH scale is a scale that tells us how much hydrogen ions or hydronium ions are present in an acidic or basic solution. So we can calculate pH using logarithms, which is a button on your calculator. But today we're just going to stick to whole numbers. So if we stick to whole numbers, we don't have to use our calculator. A logarithm tells us the power a number is raised to. But again, we're not going to focus on that, but we should just know that there is some math relationship between pH and pOH. There are a couple equations we need to know, and you'll be given the pH square for your test. So pH is equal to 1 times 10 to the negative pH. So our our hydrogen ion concentration is equal to 1.0 times 10 to the negative pH. Our hydroxide ion concentration is equal to 1.0 times 10 to the negative pOH. Here, I can easily pull off my hydrogen ion concentration, which is this number, is raised to the pH. So if I'm given hydrogen ion concentration and I want to find pH, I just pull off my exponent. Same thing if I'm given hydroxide ion concentration and I want pOH, I just go ahead and pull it off. Some other things that we need to know. Remember when we learned about our pH and pOH scale, we knew that if we looked, a pOH of 0 and a pH of 0 and a pOH of 14 equaled 14. So if we look back, we add them together. 0 plus 14 is 0. 1 plus 13 is 14. Sorry, 0 plus 14 is 14. 1 plus 13 is 14. 2 plus 12 is 14. 3 plus 11 is 14. 10 plus 4 is 14. And so on. And they all add up to 14. So that means if I'm given pOH and I want to find pH, the sum of the two will equal 14. So that's what's written here. My pH plus my pOH equals 14. I know going from pH to hydrogen ion concentration, I have my equation. Hydrogen ion concentration is equal to 1.0 times 10 to the negative pH. I can do the same thing from pOH to hydroxide ion concentration. If I want to go between hydrogen ion concentration and hydroxide concentration, hydrogen ion concentration times hydroxide ion concentration is equal to 1 times 10 to the negative 14. We won't go this way very often, but it is a good thing to know that we can get from here to here using this equation. So a couple example problems. I want to calculate the pH if my hydrogen ion concentration is 1 times 10 to the negative 4. I know that my hydrogen ion concentration is 1.0 times 10 to the negative pH. So I'm looking for pH. In this case, it's going to be equal to 4 because I just pull off that exponent. My next one, calculate pOH. If hydroxide ion concentration is 1 times 10 to the negative 9. Well, I know that my hydroxide ion concentration is 1 times 10 to the negative pOH. So if I'm looking for pOH, that means I just pull my number here, which is the number 9. So pOH is equal to 9. Going the other direction, I have a pH of 6. I want to calculate the hydrogen ion concentration. So it means I want to calculate hydrogen ion concentration if I have pH. I know the hydrogen ion concentration is 1 times 10 to negative pH. So my hydrogen ion concentration is equal to 1.0 times 10 to the negative 6. When we look at concentrations, our brackets means concentration. And our units on concentration is capital M, which is molar. So at the end here, 1.0 times 10 to the negative 6, M for molar. If I calculate the hydrogen ion concentration of a solution that has a pOH of 2, I know my pOH is equal to 2. Hydroxide ion concentration, we look up here, hydroxide ion concentration, 1.0 times 10 to the negative pOH. So that means that my pOH is 2. So hydroxide ion concentration is 1.0 times 10 to the negative 2, and my units are molar. So if up here we want to add that my units are capital M for my concentrations, and that these brackets mean concentration. There are no units on pH or pOH. One other thing to remember is that pH is a lowercase p and capital H, and pOH is lowercase b and capital OH.